Okay, welcome. This is solving systems of equations, and there's three basic types we see in Algebra 1. Two equations in standard form, one in standard form, one in slope-intercept, and two in slope-intercept. And we're going to work through each one. We'll see how the room here on the paper is. But notice on this first equation, 3x plus 2y equals 7, and 2x minus y equals 14. The object here is to use elimination method. So we need to look at it and see what method. And we're going to use what's called elimination. And we use that method. We're trying to eliminate one of the variables, either eliminate x's or y's, so we can solve for the other. The easiest way to do this, and what your brain is saying, is can I figure out, so the y's are opposite each other, additive inverse, or the x's, so they add up to 0. So what we can do is multiply this second equation here by 2. And using the distributive property, 2 times 2x is 4x, and 2 times negative y is negative 2y, and 2 times 14 is 28. That might take you a little longer. And then once we multiply that, we just get rid of it. We don't need that guy anymore. We write the other equation down again above it. 3x plus 2y equals 7. Now we see if we add these, we actually eliminate, thus elimination method. We eliminate this variable. So adding 3x and 4x, we get 7x. The 2y and negative 2y drop out. They just disappear. And then 28 plus 7 is 35. Once we get here, we can divide by 7, and x equals 5. We're going to plug that back into our equation right here. So 3, instead of x, we put 5 plus 2y equals 7. You follow? I took this equation right here, and I brought it down, and I replaced 5 in the equation where the x is. So we multiply. 3 times 5 is 15, plus 2y equals 7. Subtract our 15 over, and we get 2y equals negative 8. Am I going too fast? And then divide out the 2, and we get y is negative 4. So I've solved those original set of equations there. 3x plus 2y equals 7. And 2x minus y equals 14, and we get x equals 5, negative 4 for y, and we would put that in parentheses. It's a point where those two lines cross, 5 comma negative 4. And that's called consistent independent when they cross. So that's the math words for calling that system. It's consistent because they cross or intersect, and it's independent because they cross at a point. Alright, what method was that again? That was elimination method, and we use that when both equations are in standard form. Now we have a choice here on the second one, because one's in standard form and one's in slope-intercept. So we can use either method. We can move this 2x over and use elimination method, or we can use substitution. Now when it's set up this way, it's most efficient to use substitution method, so that's what we're going to use. Substitution. Now when are we going to use substitution method? Not when they're both in standard form. When one's in standard form, one's in slope-intercept. So where this y is in the second equation, we're going to replace that. We're going to wrap this with parentheses. And we're going to replace it or substitute it for the y down here. So we're going to get 2x plus 3, parentheses where the y was. Write our 2x minus 3 equals 15. So this reads 2x plus 3y, but we've replaced y, and equals 15 still. Now we can distribute. 2x plus 3 times 2 is 6x. You're right. 3 times 3 is 9. Now we collect like terms. 2x and 6x is 8x. Am I going too fast? Take a minute, take a break, freeze the video. Add the 9 over. I get 8x equals 24. Are you with me? Now to solve, I divide out my 8, and I get x is 3. In this case, we're going to go back to our original equation here, y equals 2x minus 3, and plug in our 3 for x, So y equals 6 minus 3, or y equals 3. So once again, I have an x and a y value, so I can write it in parentheses as a point. 3, comma 3 is where these two lines, and they're once again consistent and independent. Independent. No e's in any of these. See, consistent, independent. No e's. No a's in there. Kids are constantly putting a's in there, and these are all e's in this form of the word. Okay, our last situation is, our first situation was elimination, our second substitution. Now our third is two slope intercepts. And you can use either method. You could use elimination or substitution method here. I like substitution because since they both equal y, you can just set these two equations equal. So you can just take this portion and set it equal to this portion since they both equal y. Now we can do elimination method again, but I'm going to use substitution again. So substitution is my method. So I'm just going to take 3x minus 5 on the left side of the equation and make it equal to 2x plus 7. Subtract the 2x and get x minus 5 equals 7 plus the 5 over. That's pretty quick, huh? See, that 2x drops out and I just bring the 7 down. 3x is x, now plus the 5 over, and I get x equals 12. So where am I going to plug in this 12? Back in my first equation here at the top. So y equals 3 times 12 minus 5, which is y equals 36 minus 5. So y equals 31. Are you with me? Good. So this is now what? Solved. 12 for x, 31 for y. We can put in parentheses 12, comma 31. And we can write consistent independent again. Yeah, students are always asking me, can't I just write CI or independent? These are math words. It means these two lines up here cross at this point, these two lines cross at this point, and these two lines cross at this point. Alright, let me zoom out here and see if you can get the whole thing at once. 3 answers down here at the bottom. 3 answers. 3 different methods. Well, really 2 methods, excuse me. Elimination and substitution twice. Alright, good luck.